Hello, everyone. My name is Sànchez. I made the project of a 3D object detection for autonomous driving with my mates Lucy and Vivek, which we'll present online. But the main object is to detect for autonomous driving any kind of object. And to run our algorithm, what we did is train with two different kinds of input data set. We use for one side the NG scenes, which will be the one I will present, and for the other side, the kitty model. So let's talk about the NG scenes. This. Well, the NG scenes consist of a total set of about 1,000 input sequences and scenes, which makes much more images. Well, as you can see on the screen, according to this input image, the output should give something like that, like all the cars detected, also some pedestrians, bike. Let's talk about the results we got. But first of all, the NU scenes, as it is a set of 1,000 sequences of images, is too heavy. I mean, a current laptop or PC cannot run that because it's, as I said, it's too heavy. So for such case, there is a mini version, which is the one we used, and that consists of just 10 scenes. And 7 scenes are used for like the training the model, and the other 3 for validation and testing. As you can see here in the table are the main parameters set for the NU scenes. I mean, explaining all of them will be to enter too much in deep, and there is no time enough. Also, there are some math parameters. I would put a point of the number of epochs, which is like a bit of explanation of this is like the number of iterations we did for getting the result. In this case, we did 20, and with these results, we thought it was enough to like refuse this project. I will explain right now why. Well. But first, let's explain the evaluation metrics. For the evaluation metrics, the main parameters are the mean average precision and the NUC's detection score. The mean average precision, what makes is the evaluation of the detection algorithm's accuracy by computing the average precision of every class of object. And then the detection score evaluates the detection algorithms considering the localization and the orientation accuracy. For both of them, the higher the values indicates the better the algorithm runs. Here in this table, we can see like the general values for every sequence trained. First, we did with 10 classes of objects. And then we reduced up to the 3 main classes of objects, which were car, pedestrian, and bike, which were the ones like better detected and most probably to be found. And we got these results that compare with the voxelness reference value is way not too much. And also here is like the other table with all the results for every class of object we did, also for 20 epochs. And as you can see, it's not so high enough as the reference value. So with all those reasons, and also taking into account that this can only be done with a training version, we refuse to continue with the NU scenes, and we went on with the kitty model. From my part, that would be all.